Today in lecture, all that we really talked about was we discussed the syllabus. We went over the details of when our exams are. We went over the grading rubric for the semester. The class is worth 500 points, coming from 4 in-class exams as well as a final exam. Each exam is worth 100 points, so they have an equal value of one another. Our exams are February 15th, March 15th, April 15th, and finally our 4th exam is May 1st. Our final exam is May 10th, Friday, 8 a.m. until 10:30 a.m. Some of the take-home material from today's lecture were these 3 definitions. We defined what an enantiomer, a diastereomer, and an epimer were. And an enantiomer is a stereoisomer, or stereoisomers, that are mirror images. An example of that was D-glucose and L-glucose. We're going to get into what D sugars versus L sugars are in just a second, but D and L sugars, as long as they are the same sugar, they are enantiomers of one another. Diastereomers are stereoisomers that are not mirror images. And an example of that would be D-Ribose and D-Xylose. Now, these are both D sugars, so they have that in common. However, variation exists among several of the carbons. Then finally, our last definition was an epimer, or epimers. Epimers are diastereomers that differ about 1 carbon. Okay, an example of that would be D-glucose and D-galactose. Now, all of these names and all of these structures are going to make a little bit more sense after Friday's lecture, because we're going to look at all of our different aldoses and ketoses, but for the time being, just remember these. On the next slide, we're going to get into some questions that you should expect to see, or things that you should be thinking about with respect to these. So this first prompt, this would be a good short answer type of question, or a question that you should be able to answer with a multiple choice sort of thing. You'd be presented with multiple different structures and asked which is the C3 epimer of D-glucose. When it comes to any sugars, I always recommend knowing a baseline, or knowing like one simple structure. So I would recommend learning D-glucose. If for no other reason than anytime you take a biochemistry class or an upper division biology class, you're basically always going to refer to glucose. So glucose is an aldohexose. So as a hexose, it has 1, 2, 3, 4, 5, and 6 carbons. So of those 6 carbons, our first one has our aldehyde group, which I'm just going to write CHO. Our carbon number 6, which, let me label my carbons real quick. Carbon 1, 2, 3, 4, 5, 6. Okay, so those numbers just designate which carbon we're talking about. Carbon number 6 is going to have H2OH. Okay, now this designation right here the letter D. That's going to tell us a little bit about this structure. That letter D there tells us a little bit of information, and specifically it tells us about the penultimate carbon. Our penultimate carbon is our second to last carbon. So when we're talking about a hexose, our second to last carbon in our chain is our fifth carbon. This D designation tells us that our penultimate carbon will have our hydroxide group on the right-hand side of our molecule. Okay, so this right here, this structure that I've drawn, is kind of the framework for a D sugar. Now, if I had the hydroxide group on the left-hand side rather than on the right-hand side of my structure, I would be talking about an L sugar. So when it comes to defining and knowing the structures for your different sugars, really when it comes to your hexoses, all you have to know is the orientation of our hydroxide groups about carbons 2, 3, and 4. Okay, when it comes to glucose, what you'll want to do is you'll want to have carbons number 2 and carbon number 4 with a hydroxide group on the right-hand side. OH. Carbon number 3 is going to have a hydrogen on the right-hand side and a hydroxide group on the left-hand side. Go ahead and fill in the rest of these carbons, positioning those hydrogens and everything like that properly. Now, this is our structure for D-glucose. We are asked for the C3 epimer. So an epimers are sugars that are basically the same with the exception of one carbon. This is asking for the C3 epimer. So to draw the C3 epimer of D-glucose, everything's going to be the same. Still going to have 1, 2, 3, 4, 5, 6 carbons. And it's still going to have CHO. It's still a D sugar. Carbon number 4 is going to be the same. Carbon number 2 is going to be the same, hydroxide group on the right-hand side. But this carbon number 3 right here, we're going to have a hydroxide group on the right-hand side. Okay, so what this tells us is, well, basically if you make an epimer, a C3 epimer of D-glucose, this is what it looks like. Now a good question is this glucose? And the answer to that question is no. When you change the positioning of one of the hydroxide groups, you're no longer talking about glucose. This, in fact, is allose. So that would be a good way that you can draw relationships and connect sugars to one another. So if you said the C3 epimer of allose, or the C3 epimer of D-glucose is D-allose, that would be a correct statement. So, like I said at the beginning of the last slide, you should have kind of a foundational molecule to draw, and I recommend D-glucose as that molecule. D-glucose. What we have is D-glucose is an aldohexose, so we've got 1, 2, 3, 4, 5, 6 carbons, H2OH, and HO. Okay, CHO, CH2OH. Now, D-glucose is going to have a hydroxide group on the right-hand side for carbon number 5, because that's our penultimate carbon. That designates a D sugar. Carbons number 2 and 4 for glucose have hydroxide on the right-hand side. Carbon number 3 has a hydroxide on the left-hand side. So then all that I need to do is fill in the rest of my hydroxides and my hydrogens. I am asked to draw L-glucose. How am I going to do that? Well, I know that the first variation between D-glucose and L-glucose is carbon number 5. So that's 4, 5, that's 6. Okay, carbon number 6 is identical. Carbon number 1 is identical. Carbon number 5, however, that's where variation is. Okay, so by putting the hydroxide group on our penultimate carbon on the left-hand side of my molecule, I have established that I am drawing an L sugar. Now what I need to do up until here is basically get all of these other hydroxide groups to conform to line up with that. So hydroxide group on carbon number 4 is going to be on the opposite. side as the D sugar. Carbon number 3 is going to have my hydroxide group on my right-hand side rather than on my left-hand side. Carbon number 2 is going to have my hydroxide group on my left-hand side rather than my right-hand side. So by doing this, by flipping one of these carbons, what I need to do is basically position all of my other hydroxide groups in a manner that reflects and puts these on the same relative sides, puts the hydroxide groups on the same relative side. So here is D-glucose and here's L-glucose. I started drawing L-glucose by repositioning my penultimate carbon's hydroxide group, but then I had to get carbons 2, 3, and 4 to have hydroxide groups that more or less are the same, they have to be the opposite of what D-glucose has. So this right here, this question, or this prompt is draw a C3 epimer of D-ribose. We first and foremost have to know what D-ribose looks like. D-ribose, well, it is an aldopentose. So it has only 1, 2, 3, 4, 5 carbons. CH2OH. It is also an aldose, so CHO. It is a D sugar, so OH. Carbons 2 and 3, however, those are the ones that we have to consider when we're drawing D-ribose. So all that we're going to do, and what you should sort of use as a foundation, is to recognize that all of my hydroxide groups for D-ribose are going to be on the right-hand side of my molecule. So what we have is all my hydroxide groups on the right-hand side of the molecule. This is D-ribose. What I need to do, and what I'm prompted to do, is draw a C3 epimer of D-ribose. So 1, 2, 3, 4, 5. It is still an aldopentose. We have 5 carbons. It is still a D sugar, because where is my variation coming about? My variation is about carbon number 3, not carbon number 4, so I'm not changing that. My hydroxide is on the right-hand side. Carbon number 3, however, I'm going to have a hydroxide group on the left-hand side of my molecule compared to my structure for D-ribose. So I've got OH. So is this D-ribose? No, it is not. Instead, it is D-xylose. Now, this is something that we're going to get into a bit more on Friday, because we're going to be discussing all of our different aldoses and everything like that. But this will kind of get you thinking in that direction of what does this look like, and what structure am I doing? Am I changing the sugar when I make a D, or when I make an epimer? And the answer is yes, but we'll get into that more on Friday. All right, have a good one.